Hi everybody. Happy Tuesday. It's Tuesday. How's it going? It's time for my Cody stream thing. And I'm doing it at a slightly different time today, which has unfortunately resulted in this the sun being right behind the shades in my house. So sorry about the white line cutting through the scene. It'll be there the whole time. Anyway, let's get right into the coding stuff today. So let me switch over to, oh my gosh, what am I working on? Here's the slide deck that is describing what I'm working on today. So today I'm continuing on with the same project I've been working on for like the last 5 streams or so. This demo for work stuff called Cloud Spin. And what Cloud Spin is a demo that uses a bunch of different components from Google Cloud Platform. And, oh, I'm disappearing in the chroma key. I guess I foolishly wore blue with the blue chroma key right now. I'm afraid I only have green and blue chroma keys, so I'm just going to be slightly vanishy today because it is too hot for me to put on a hoodie. Anyway, back to the actual demo. It is a demo. The demo involves a whole bunch of phones, which you can see in the background of this. There's like a big metal frame. Let me make that a little bigger. Boop. There's a big metal frame, and there's phones behind a person. And what happens is that we tell the person in the middle of this big ring of phones to jump. A bunch of phones, Android phones, up to 19 Android phones, capture a bunch of video clips, which we then process, and we extract out a bullet time, like that Matrix movie, freeze frame of them at a certain moment in time, preferably when they're jumping or doing something else cool. This is a demo that we actually built a few years ago using a whole bunch of different components of Google Cloud Platform. And we hacked it together real fast. And it was great. And people love it. And they love it so much that we're going to take the time to do a reimplementation. We're reimplementing because there are new shiny features that are available now that we'd like to show off. And because the original demo, it was our first time doing it. We learned a lot about challenges that are faced, and right now it has a very long setup and strike time, and we'd like to bring that down. So the reimplementation is built around a couple newer parts of Google Cloud Platform. We have Firebase, which is a wonderful SDK for building mobile and web applications with a big old bag of goodies. Specifically, I'm using the Firebase client libraries in node.js for this project. And then for a lot of the processing, we end up having lots of bursts of traffic. So I want to do kind of a serverless approach to it, which drives well with the Firebase clients. And for that, I'm using Google Cloud Functions to do most of the server-side processing. And I've broken this down into a bunch of different components. Earlier on in the stream, I spent time taking a selection of frames that are identified from one particular slice of time and turning them into the animated GIF. That's all done and working. So moving on to another randomly picked chunk of the architecture, which is what I'm working on today, which is extracting all of the frames from the video clips and doing that from a cloud function. So basically, all of the Android phones are going to upload video clips, so 19 simultaneously executing video clips. And then what we're going to do is we're going to extract all the frames from the videos, maybe not all of them, but a whole bunch of the frames from the videos. And then we can figure out which of those frames happen at the same moment in time. And then we can make the GIFs from that slice of time. And here is the architecture of the thing we are building, which is something I've shown, I think, every stream I've done. We start with phones that are uploading stuff. In this case, they're uploading video clips, 1 video clip per phone. So you might have 5 or 10 or 20 video clips going out. Those are going up into Google Cloud Storage. And them showing up in Google Cloud Storage will trigger a function to run. And what that function will do, at least in the initial version, is it's just going to extract every single frame from the video. So for like a 5-second video, we're going to get 5 times 60. So what is that? 330-ish frames are going to come out. Is that right? Something like that. And so we like a 5-second video clips, we're going to extract all the frames because it's running at roughly 30 FPS. Then we're going to take all those frames out and we're going to write them back to storage. And then we're going to use the Firebase real-time database to do signaling so that downstream systems know when we are done. then the downstream system is going to download those frames and do the downstream processing. In that case, it's going to figure out which ones happen at the same moment in time by getting some information out of the frames, and then building a collection of GIFs that the user can sample from. Okie doke. So without further ado, let's get on into the code. And yes, if you are watching and you have questions or comments or just want to say hi, please do use the chat. I keep an eye on it, and I love talking to people while I do this kind of stuff. So let's get on into it. So here's my integrated development environment thingamajiggy. Let's reorganize some windows off frame. Oh wow, I'm pretty invisible on that side. That's pretty neat. Finally got a big enough view into my own little preview. And here's where we left off. So this is actually the second session. Oh yeah, the to-do list. I should go get that from that keynote deck. What are we actually doing today for reals? So this is the second stream of this particular component of this larger demo project. Last week, we figured out how to extract frames using ffmpeg on the command line, because I have to admit I have limited experience with ffmpeg. Then we used the process spawning to basically run that command in node.js, which is like a single line of JavaScript, nothing too fancy. And then what we want to do is we want to do that thing from a deployed cloud function. Because I know that so ImageMagick, which is in the previous module of this whole streamy project, it's actually already there on all of the different cloud function nodes. So we didn't actually have to install anything. We could just call out we could just spawn a process and run it. But ffmpeg is not there by default. So we have to figure out how to get the binary, let me remove the strike through. We have to figure out how to get the binary up there or find some other way to use the deployment process to get ffmpeg up there in some way, shape, or form. Because you can actually push any binary you want up there, or so I've been told. I've just never done it before, so you get to see me figure out how to do that. Sound like a plan? I hope so, because you can't talk back to me right now because you're on the other end of the internet. Anyway, so what we're going to do, the first thing we're going to do is we're going to take that Node.js version of the frame extractor, and we're going to try and do that same thing deployed from a cloud function. Then we're going to start wiring it up to the storage bucket so that we can fetch the video from the storage bucket, and that'll also do the trigger. So where we'll have a mobile phone, upload a video, or we'll probably just drag it in on the console, and then that's going to do the upload. Another thing is we ran into some issues with permissions in the local dev environment, which is because reasons having to do with credentials. Authentication is always complicated. But the gist of it is right now, I don't have a local dev environment that can talk to the cloud storage buckets, so we're going to fix that. And then these are actually redundant now. Then we're going to put the frames back into a bucket, which will hopefully be pretty easy then. And then at that point, we'll have something working. It'll be a nasty mess of a disaster. So the next step, of course, is to clean that up. And then after that, we'll do some wiring it up into the real-time database so we can start to integrate it with the other components. Basically, so we can send a signal downstream so that our same time frame identifier function to be finished will run. Okay, so let's get in there and do stuff. So let's just make sure what we had last time is still working. So let's go into my directory with all my stuff and make that a little bigger so it's easier for all you to see. And okay, what we got? So we have in the fodder directory, we have a video that I took of my coffee mug, which is what we're using for all of kind of the demonstration. It is a little GIF of me dragging my phone around a coffee cup. It is in portrait mode because that is all of the videos coming off of the Android phones in the real demo are portrait because you get taller jumping GIFs then and people do that cool stuff. And we're going to be using that video for the sample, so that is still there. Let's take a look at our function. We're going to go into functions directory. What do we have here? We have our frame extract.js, it's actually in index.js. So in index, we have our frame extract function written right here, which is also available in the IDE. Boop, up here, index.js, frame extract function, a little bit prettier, make it a little bigger for easier seeing. There, okay. So we have our frame extract function. Let's just make sure that we can still deploy it. Make sure that I have not broken anything. Oh, I think I actually have. So I have actually unauthenticated my Firebase client. So I'm going to go into super secret mode, boop, real quick, and I'm going to re-authenticate my Firebase client. And the reason I am in super secret hacker mode right now is because not only is this showing all the email addresses I use for various Firebase tasks, but when I do the login step, it actually displays a magic URL that you could use to hijack my session if I were to show it to you. And I don't want you to do that, because I want to be productive today. Okay, so let me, boop, Firebase list. Listing my Firebases to make sure I authenticated with the right one. Now I'm clearing out my terminal so that if I accidentally scroll up, I don't leak out those things. I just put a lot of effort into not leaking out. And go back to where I am before. So basically, all the commands, I'll show you the commands I ran. Going back into live mode. Okay. So the commands I ran, because I was logged into a different Firebase account, I used the same Firebase command line. I just did a Firebase logout, and then a Firebase login. Which is all you have to do when you want to switch accounts. And when you work with Firebase a lot, like me, especially with I have different groups I collaborate with, I have a lot of different Firebase accounts I use. Anyway, making sure that we're logged into the same one, I'm going to do a Firebase list, and I can see that Giphiator is the one I own, and it is the only Firebase I own, because I created this account specifically for streaming. Now we'll do our Firebase deploy, and this should just be deploying the same thing we already had up there. So it's not going to be terribly exciting, but it'll verify that I haven't broken anything in the back end somehow. So that'll run for a minute, and while it does that, I'm going to get my console up and ready to jam. Console, no, I don't want console.cloud. I want console.firebase.google.com. This is where we're going to be seeing all our stuff do its magical stuff. Whoop, let me drag this down so I actually know where my little shared screen segment begins and ends. So going back to that browser, we have our Giphiator. Bring the terminal up so we can watch it redeploy everything. Hey, everything deployed. Yay. Then we go to functions. We can see our functions are listed. We should see 2, and we do. We have our Giphi's, which is triggered by a real-time database right to a certain location, which is how we're going to kind of do a join operation downstream. And we have our Giphiator video clips. If we go into logs, we can see where we left off last time. There was an error where it tried to run but could not find the ffmpeg binary with which to spawn. There we go. Spawn freaked out. It's like, I can't create that child process because the binary is not there, which of course caused our function to exit sad-like. And it says it exited okay because my promises are poorly written. That messy part. I didn't actually handle the error. I just logged it out. So what we want to do is we want to get ffmpeg bound up to Node. And there are actually better ways to do this, I learned from some research. If you just search for ffmpeg and node.js, this is of course not a unique thing. People have a bunch of different implementations out there. And let's take a look at a couple of them. You know, the ones high up in Google tend to be useful. So we have API for Fluent API to ffmpeg. So this is one thing we might potentially be able to use. This looks like it might have a little more heavy stuff because I'm not actually familiar with Fluent. So this might be overkill for our needs, despite being the top result. looks like it has a pretty nice API. I prefer kind of a skinnier API. Called ffmpeg. This is a library that provides a set of functions and utilities to abstract command line usage of ffmpeg. To use this library, it requires that ffmpeg is already installed. I don't think that's actually going to help us much. This is a wrapper around the process spawning, essentially. So let's keep poking around. Remember there's one I saw someone else use before. It's like ffmpeg.js or something like that. ffmpeg.js. So it hasn't been touched in a while, but I believe I've seen this in Cloud Function implementations before, where it is a library, provides ffmpeg builds ported to JavaScript using mscript project. I'm sorry, I can't read that. That word's too hard for me to parse in my brain. And we're optimized for in-browser use. So it's a JavaScript implementation, which explains why I've seen people use it before. So it might not be the optimal solution, but I've seen it working before, and I'd like to actually get something working. So we'll try out other ones first, but since I'm pretty sure I've seen this one working before, we will give it a spin. So npm install, let's give it an install. ffmpeg.js. So this means we're going to have to take a step back, and we're going to have to actually implement what we did before. Before we did process spawning, now we're going to have to use this API because we're using essentially a JavaScript native implementation. So do they have examples that read stuff and stuff? Okay, so these seem to be taking data from standard input or standard output. And here's an implementation that looks from a file system, so, you know, like a reading from a file, which actually looks like a good fit for what we have. This looks like it might be a good fit. So let's give it a spin. Let's go back over to our function. Let's actually go to this. We don't want the frame for this. Okay, this is our frame extract function that didn't really run that well independently. So let's go on over. Since we're taking a step back, let's create a new file. No, let's just do frame extract. So I'm just going to take this old frame extract function I did before. Boop. And I'm going to convert it on back to the implementation we had once upon a time. So, boop. Let me just clean it up into old school function looking. Function extract. Okay. So name function extract. Then we're going to run it. We don't need that semicolon. All right, so just a little wrapper to run our function. And then, so what is this doing right now? Okay, so it has a session ID and a clip that are hard coded. Oh yeah, let's actually add the dependency. So now we have ffmpeg, and what this is doing is it's going out to that bucket. It's downloading coffeetime.move, move. It's copying it over to a temp bucket, and then, oh, this is where we ran into the permissions issues with the storage. So, well, let's short circuit that for now. Let's comment out the bucket stuff. We'll loop back later and fix that, and we're just going to read it locally. So let's read. So this is currently, it's creating a video clip bucket. Oh, so this is downloading from the bucket, and then it's calling another promise. So what we want to do is we just want to run just the frame extraction. So this is the command we were running before. We just want to run this in new shiny ffmpeg type format. So we're going over to here and see the different implementations. So we wanted something like this. The input. Okay. So grab that. Okay. So result equals ffmpeg memfs. What is this memfs option? Files
M3 will support several file systems using memfs. Oh, it's because this is designed to run in a browser and we don't actually have a real file system available. Interesting. You know, I think I know a place where this has been used before. Ironically, in my own GitHub. So I'm going to go take a look at that. And it's actually not code I wrote. It's code I open sourced that somebody else wrote. But I'll take a look at it anyway. So it's only used for audio processing. This is from a different demo we did, a universal translator. But if I remember right, buried in one of these cloud functions, there is an implementation, or it's something that uses ffmpeg-JS. No, maybe not. Let's take a look at index.done.js. So everyone's just using translation. I thought it might be using it for, oh, it's using it in the browser for that. I haven't actually done ffmpeg in the cloud function. Okay, let's look at another place. I remember someone wrote a pretty slick blog entry about ffmpeg in cloud. Oh, it's Josh. Josh Beckworth wrote it. And in the end, Josh had trouble actually using it, but mostly just because of the large video size that he was dealing with. So let's see how he dealt with it in the implementation. So this is him writing a dev server and a test script that pushes stuff into it. And there we go. Oh yeah, you can actually use ffmpeg-installer, platform independent binary installer of ffmpeg for node projects. Hey, this is actually perfect. This is the cool thing about the internet. Josh did the research that I was toe deep in. And so we can probably uninstall ffmpeg.js. We can install this one, ffmpeg-installer. And he says, hey, neat, I can run ffmpeg, but I can't write anything to disk. This is one of the limitations of the serverless environment. You should be able to use it. Anyway, you should be able to write to at least temporary directories. So this might be enough to get us working. So let's take a look. ffmpeg, oh, that's just getting the path. Okay, so let's take a look at ffmpeg-installer. Boop. And see how it's supposed to work. It's a platform-independent ffmpeg installer. So would it just be available? Like is it just going to be in the path automatically? So it looks like that might actually be the case. That's pretty cool. With process.spawn. Okay, so it looks like the stuff we're doing might actually just work. So ffmpeg path, where does that get defined in this? Ah, okay, so we need that. Interesting. Okay. That's pretty cool. This might just work with the implementation we already have. So if I go back to the index.js file, the bigger program we worked on before, I can probably just get this working. So we have child process.spawn already. And then this is actually doing the spawning and the execution. Let's see if this works. So let's grab that, because that's the process we're going to spin up, ffmpeg path. We're going to go down into this spawn command. Where did I spawn? There we go. Spawn, except instead of just spawning ffmpeg, we're spawning ffmpeg path. All right, well, let's just deploy this. Let's see if it works. Oh no, that didn't work. When I tried to, you should always wait to see if things actually run. 404 on ffmpeg installer is not in the npm registry. Oh no! What the heck does that mean? Did I make a mistake? Oh yes, I made a mistake. There we go. Let's install it the right way. Hey, that did a bunch of stuff. Alright. I don't actually know enough about npm to understand. Oh, hi Slayer Darth. It's a little later for you today. Good to see you. Okay, no. Okay, Firebase deploy. Let's see if this will send those binaries up like magic. I don't actually know much about NPM. I've only used it in kind of trivial cases. So I'm actually really impressed that I can just like have it go and run arbitrary commands and binaries, which makes me a little bit concerned from a security perspective that I just randomly npm install stuff all the time that could be installing random binaries all over the place. Powerful dependency management tools often are a little bit of a double-edged sword in that regard. So we're letting it install again. Cloud Functions can take a couple minutes to install. So you do the installation dance. Hey, the installation was successful this time. And if all works well, this will just automatically work once we give it a kick. So we go back here. We take a look at our Cloud Function stuff. And Slayer DAR 3 parts, the lag is real. Yes. I can probably blame Comcast for that. It might be coming through on my end. Or just the fact that the streams like to buffer, because that's what streams do. Okay, so we were going to go to storage. So we want to be able to see logs. I should probably get a proper tiling window manager at some point, so we can look at this stuff. So I don't have to spend all this time dragging windows around. And so I discovered this kind of little pop-out thing. There it goes. Okay. So we want to go to this one. Took the video clips. And we want to drag a video clip in. I'm just going to delete both of these, which is probably going to make the program freak out a little bit. Because it's actually, I didn't tell the function yet how to distinguish between delete events and creation events. So that probably just made our function a little grumpy. We can even see in the logs. Did it? Hey, it exploded right away. I was like, I tried to download it, but I couldn't because it was a delete event and it was being gone. So let's upload the file this time. Oh, it already knows about that path. It's uploading up there. Let's take a look at the logs. You can see the little upload going. Yeah, Slayer DAR 3 ports. The log is from glorious 1080p60, which is probably, yeah, apparently you have to be famous enough to get all the different real-time streaming transcoding stuff. So someday, everything will be awesome enough, and then I'll be able to do the streams. I could probably lower my frame rate though, which might make it a little bit easier. Okay, so we have an error. We have this thing grumpy. It says one of the downsides of these kind of serverless environments when you kind of like test by deploying is sometimes the error messages you see are a little decoupled from your code. Like I don't even know if my code is in here at all, which is a little annoying sometimes. Okay, so this is saying it is sending a request. It's trying to get something from Google Cloud, from a util.js. It's parsing an HTTP response, and it's like not found. But it doesn't actually give me a line in my code, so I don't know where it's oh, there it is, from index.js, line 112. So if we go back to index.js, and there is no line 112. So that would imply that it's some kind of translated line number. That's not very useful. Okay, so let's see. Is there any easy thing that I've done? Like, is there any obvious error I have here that could be monkeying stuff up? Let's take a look at that error message again. So when I tried to run, so it ran really fast, 400 milliseconds. Well, not really, really fast. So it did a little bit of work. And then it's something in storage. And it got a 404, or a not object, it got a not found from the API. Oh, I wonder if that's the message from the deletion event I did earlier. Nope, still not found. Okay, let's go back into storage. Let's just try uploading it again. Why not? Into session 01. Upload. Oh, well, the file name's different.
I'm a bonehead. So right now the file name is still hard-coded. In my software to just look for coffee time dot move, which is kind of silly. Is that really what I'm doing? Yeah, that is seriously what I'm doing right now. Because there's no event coming in, so it doesn't know. Oh, but there is an event coming in. I just have not rewritten this part yet. Fair enough. Well, let's stick to the course we've already done. Oh wait, I don't have to redeploy. I've renamed the file. I can just do that. So if I upload a file, basically what's happening right now is when any event happens in the storage bucket at all, whether it's a deletion or creation, it looks for coffeetime.mov and then tries to do frame extraction on that. And so coffeetime2 got uploaded, so it went to look for coffeetime1 because it's still stupid because it's a program and I haven't told it how to do anything yet. So we'll turn our logs back on live. And so we have this one from a few minutes ago. Wow, it took me 4 minutes to figure that out. That's one of the downsides of having these precisely timed logs, is it tells you exactly how long it takes you to get through silly problems, which is sometimes really sad. And it's running, and it's still running, and oh my gosh, it extracted frames, or it's trying to extract frames, which means if we go to Giphiator frames, there's nothing there yet. And right now it's running at the default size Cloud Functions VM, which is very tiny. So we might actually have, it might run out of memory. Oh, there it goes. Memory limit exceeded. So at some point I will clean this up and make it run more efficient, but I don't have time for that right now because I want to get this thing working from end to end. So I'm going to go over to the kind of the back. So if the Firebase like polished shiny client library is kind of like a nice smooth front end with a lot of good assumptions made, there's the real Google Cloud Platform console. Actually, you can do a lot of operations on the same cloud resources that you use for your Firebase stuff. So I can go to the Cloud Functions, and if I go there, I will see my same Cloud Functions that are getting deployed by the Firebase SDK. And I can see that my frame extractor is currently a super tiny VM with only 256 megs of RAM. What I can do is I can go in here and I can be like, no, I want you to have more power, which of course costs more. So I probably want to lean it down for production use, but for the purposes of like development, I usually just max out the VMs. And this will be sticky. So as long as I don't change the name of this function, it'll stay sticky. So this takes a couple seconds. You can see a little spinner up here spinning. Once that spinner's done, this will be up there and ready to receive requests that consume more memory. So I wonder what, like, one thing I'm curious about right now is if I go back to, while it's doing that deployment, or whatever configuration change is going, I wonder if I just upload the same file, does that trigger an event? I would expect it to trigger an event in case there's been a change to the file. So I'm going to do that right now. I'm going to upload the same file again. I'm just going to overwrite it. And there are 2 entries here now. Let's see if they consolidate into one. Going back to this, hey, that's done. Hey, consolidated it. And did this trigger another event on the Cloud Function? Our little log bot is running. Extracting frames. There was a question. Slayer Darth asked Jen, want to hazard a guess how much RAM I have on like your desktop computer? I don't know. It depends on what kind of stuff you're doing. I'm going to guess 32 gigabytes of RAM. That seems like a good workstation amount of memory. Is it 32 gigabytes of RAM? Okay, so the frames are extracting. Yeah, once upon a time, I worked a lot with the Android kernel. I had a lot of RAM on that workstation. When you're building like a 1 gig of RAM, oh, Sardar says 1 gig of RAM. Is that because you're on a mobile device, or do you use a workstation with 1 gig of RAM? Are you that lean? 1 gig of RAM it seemed like a lot back in the day. I remember my first computer that had a gig of RAM. It seemed gargantuan. Oh my gosh, I didn't notice. The function executed successfully. And if we go over into storage, we might just see, oh yeah, because I didn't actually implement that last part. So right now what it does is it extracts all the frames and it just throws them away because it's kind of a jerk. And it just wants to waste CPU resources. But if we go back to functions, we can still learn a little bit just from this log event about what happened. So we're going to go look at our frame extractor. And we see that it ran for 36 seconds. Kind of long. But one of the cool things is when we have 19 phones, we can do all 19 in parallel. So your Darth reports is on an 2008 Dell Latitude E5400. I don't really remember that model, but it is a computer from 2008. I'm glad to see you're still getting the use out of that. I have an old ThinkPad I use a lot too, which is I think it's from about 2011 that I use a lot. It's kind of nice that we finally live in a day and an age when you can actually run a lot of modern stuff on older computers. Okay, so going back here, we have it running. Let's finish off the whole flow and get it to the point where it's writing something back to that destination bucket so we can actually see something up there. And we already have, so we're just going to add another promise to this chain, which is going to do our last step, which is going to upload little auto formatters. Okay, I wanted to put it there. Whatever. I will let the IDE do what it does. That's an interesting place it chose to do that. Does that? Okay. If you IDE, sometimes the auto formatters do interesting things, and I'm not going to fight it. Oh, that makes sense because this parentheses matches up to that whatever. So what this is going to do is upload the frames to our to cloud storage. So we have some number of frames. We actually don't know how many frames we have, but we know they match this expression. So we're probably going to have to find the frames in this temporary directory and upload them all. What if I can just upload the entire contents of that temp directory? In which case, I should probably make a second temp directory because I'm going to download the clips there. Okay, so right now the temporary directory only contains thumbnail or the frames, the extracted frames. So we're going to just upload the whole contents. There's called storage, everything in tempter for now. Neat. Oh, and now it wants to stick, whatever. It wants to put my cursor all the way back out here. It seems that my IDE doesn't really know what arrow functions are. That's okay. So Darth reports, a lot of my older hardware runs well on Linux. And Windows and Mac, it will obviously choke to death. Yeah, it's amazing what you can get by with like old Linux systems. I've actually seen people who run web servers on their old Android phones that they had root on, which is really, really cool. Because then you end up with a super power efficient web server with a screen attached. So it's better than a Raspberry Pi in that regard because they can actually, like, if there's a problem, they can just see the console on the physical screen, which is super neat. And it's probably more power efficient because you think about it, even older phones, like, they ran a long time on a battery, way longer than a Pi does, which is always neat. Anyway, so we want to upload some stuff to cloud storage, and we did this before in a function just up here higher up. So it is upload by file name. Should probably return this promise. And from the previous step. So now we want to upload the frames to cloud storage, everything in tempter. I wonder if this can... This is upload function. What does it let me do? So diving into the source code. What are all the different things I can tell it? Is it only file names? Can I give it a path? You give it an encryption key, so you can actually have your own encryption key for buckets. So, but does it allow wildcards? Are there other upload functions I can use? Does not look like it. So these are mostly functions for flipping ACLs around, for getting metadata. So it looks like I'm going to have to list all those files. And then upload them one at a time. Still scrolling through this, looking for some magic. This is almost all bucket manipulations. There's nothing that has more oomph for doing local, file system stuff. So I have never done this before. I'm going to get to do research. So let's bring up a web browser again, and let's search around for stuff. Let's take a look. I'm assuming this is in the file system library. So if I just want to list a directory, there's probably a function like list or ls. lstat, list. Let's just look for list. File sync, read file, write sync. It doesn't seem to give me a lot of, I can make a directory, I can change a directory. Maybe it's in, I expect it to be in file system. Well, let's do the thing you do when browser search doesn't work. You use web search. Let's list everything in a directory. And hey, there's a knowledge card for it, which is pretty cool. It's considered a read directory. So we're going to read a directory. Read-dir. Here it is, read-dir. And I can do it asynchronous or synchronous. So, oh wait, I made a mistake here. This is not actually returning a promise. This is a promisified version of it, but that is not it. Okay, so of course I want to read file etc password. No, I want to read a directory. Read directory, asynchronous, read-dir, reads the contents of the directory, and then the callback gets two arguments, error and files. Or I can do it synchronously. Returns an array of file names, excluding dot and dot dot. Okay, so let's take a spin at that locally. So let's go over to another, tinker around with it. Actually, I can tinker around with it in a REPL. So import, okay, let foo. Okay, we got our file system, neat. So fs.readdir, what does that do? Path must be a string or buffer. So if we give it a path, that's because it's calling a callback. Readdir sync. Does that return a value? Hey, it does. That's pretty fast. So the cloud function, it should probably do this all asynchronously. I'm just going to do it synchronously because I'm crazy like that. So what we're going to do is we are going to, so we want to upload all of them. Can the upload take a list of files? Let's take a look at that. So Google Cloud Storage, actually Firebase, is Google Cloud Storage for Firebase is actually what we're using. No, are we using the direct API right now? We're just using Google Cloud Storage API directly. So this might be a little article in itself that might be useful. Just a code sample of uploading all of the files in a directory to cloud storage. Oh, I can actually use the I could spawn a process and use gsutil to do it, which seems kind of silly. But this is doing it from form images.js. Here's an example that's up there. It's streaming stuff around. I don't want to stream. I have files to upload. This is all dealing with, that's a pretty involved sample. Oh, because it's in the middle of a tutorial. That's why. I'm like, that sample seems to have lots of context. So let's go to this through the products. So we're going to go here. We're going to take a look at storage. We're going to go to my own documentation. Docs are linked from here somewhere, right? Usually towards the bottom. storage docs. I will just URL hack because I know how to get there. How-to guides, perform specific tasks. But what we actually want to look at is we want to look at the API reference. We want to see, is there a way to upload a list of things? Update, okay, so that's buckets itself. Channels, objects, updating objects, that's all doing remote manipulations. What am I using right now? I can't see it here at all. Am I using the Firebase SDK? Let's go take a look at those. Because the Firebase SDK defaults might actually be good enough for us. This is all client-side stuff, which is okay. So I didn't see. Okay, deleting buckets, managing buckets, listing buckets. How about uploading files? See if there's another example out there. If there's some existing stuff. And it goes back into this tutorial, which is uploading it from a stream, which is probably a good implementation for that tutorial. But that I just want to upload a file from my file system. Let's go into the samples repo. There's a lot of different samples out there. Sometimes poking the right one can be a little tricky. Okay, Google Cloud Node. This is the client. And we can look at storage. This takes us back here. Okay, I'm bouncing around, looking for a sample that hits my thing perfectly. I don't think I'm going to find it. I'm just going to code, because why not? Okay. So from a design standpoint, what do I want to do here? What is actually going to work well? So we're back to index.js. So I want to upload the frames to Google Cloud Storage. And I'm going to have a bunch of frames, like probably 100-ish frames. So if I do file system list on let files frames. Okay, let's take the frames. Is that actually going to, it's not going to change. So it's const, and that is equal to our temp path, tempter. So we're going to list all the files in there. Got all these frames. We're going to log out and see, make sure, and then I'll do a sanity check to make sure we actually have the frames we think we have. Then we want to upload them all. So I'm going to do this the stupid way, the naive way. So for frame in, so we'll do them sequentially one at a time, which is of course not the way to do it at all. Is that actually even how you do a function for each loop in JavaScript? I actually don't know. There we go. And what we want to do is we want to tempter, boop. If this works, I'm going to be shocked. And this is the downside of not having spent the time to create a local dev environment that like works right. Let's do this again in the REPL. Woot. For REPLs are great for this kind of tinkering. It's like I vaguely know this language. Frames is not defined. Oh, it's because I didn't define it. So now we have frames, and hey, it logs out. That's what I remember. There was something weird about that. Yeah, there we go. Those are the actual file names. I remember there was something weird about for each loops in JavaScript, and it's because it gives you the index, not the actual object. Like, yeah. Okay. And I'm sure there's really good reasons for that down in the language implementation and how they make associative arrays and all that stuff work. Which I know there's dragons down there. I've poked them before, but it's been long enough. How do I exit the REPL? That's how. Okay. Firebase deploy. Let's deploy our thing again and see if my terrible implementation, which will probably run for a very long time because I'm doing the uploads all sequentially, all lots of them. Let's see if it's able to upload any of those frames. Then we'll go back and we'll actually clean this up. And it's like just after 3. So I've been coding for like 45 minutes now. I'm going to code for about 1 more hour today. A little longer stream than usual. Then I'll be preparing because I'm going on the road again. I'm going to be in Poland next week. So I'll be streaming from the road on hotel Wi-Fi, and we will see if that is a success or a disaster. I expect it to be a disaster, and I'll probably be streaming at a much smaller frame size to accommodate whatever bandwidth I manage to find up there. And hey, it's deployed. Okay, so let's run this again. We'll give it a kick, and then we'll start cleaning this stuff up. So just the frame extraction ran for like 30 seconds. Okay, so I'm deleting movie 2, which is going to trigger a something happened notification to the function. Then it's going to go look for coffeetime.mov, and it should do some frame extraction and stuff. There's a little latency with the logs, but they are running. It is extracting the frames. Then we're going to get some giant log event where it lists out like over 100 frames that it extracted. Because I actually don't know which frames it's extracting. I think it's just extracting the F frames. I don't know if it's the same as like a P frame. Like one of the frames, you know, one of the keyframes essentially. A frame that has all of the data in the video. Or is it actually doing, or is it P frame? I don't remember enough about videos. I know they're like magic, video compression. So I don't know if it's uploading. Oh, there it goes. It ran. Oh, and it finished with status error. So extracted frames, and then it went, wah, I'm grumpy. So it got grumpy between here and got all these frames. So the code formatter seems to have gone insane. Maybe I need WebStorm or something. Where is it in that? Actually, I don't know if it's just my, oh, there it goes. There, okay. So it's slightly less insane now. Apparently I was hitting the wrong hotkey. Okay. About this stuff. So it might just be angry because I'm trying to do this in sync. Because I know I'm mixing different programming paradigms here. And that might be making it all grumpy to the max. So it is deploying again. The bummer here is there was an error, but it didn't tell us anything about that error. It just said, I ended with error. Oh, really? Oh, is it because I didn't return anything here? But it also didn't log out this part here. So I suspect that it went a little bit wonky right here. Well, I can do this on the REPL also. Oh, but it's already deployed. So I might as well just test it this way. So going back here, we're going to upload coffee time again. Going to overwrite the file. And there's probably a faster poke I can do to get this thing poked, but I will stick with what I know worked. So I can save some cognitive load for something else. So it is running. Again, the logs trail behind for a few seconds. So we should see it catch up in a moment. It's extracting the frames. This took about 30 seconds last time before we got the sad message that it had decided it was done for the day. So either I'm doing something wrong in that promise where it extracts the frames, where it actually spends the computation time to actually extract the frames, and then when it tries to go to the next promise in the chain, it gets all grumpy. Or there's something wrong with the way I'm reading the file system. But we are about to find out. Oh, hey! Well, that's an easy thing to fix. It sees coffeetime.mov, and it says GIF bucket is not defined, add video clip. Okay. So that is a much more useful error message. So GIF bucket, it can't find, it says GIF bucket is not defined. That's because GIF bucket is not defined. My IDE even tells me, missing import statement. In other words, this should be called frame bucket. But one other thing happened, which makes me wonder why I crashed before. I don't know why I got all grumpy before, because this one did tell us. It says in temporary directory, there's a coffeetime.mov, which means that us doing the frame extraction is either not getting the PNGs, or I'm actually going to make it a little faster. Here's a trick to make it faster. You get bitmaps instead. Oh, but that'll take longer to upload. Oh, but it should be faster to upload. Okay, we're bitmaps. So if you just tell ffmpeg to extract frames that are bitmaps, it runs way faster because it's not doing any of the image compression. Instead, it's just making huge files. But the files are much longer, so it can take a lot longer to compress them or to upload them to the next step in the chain. So did we get the about to list stuff? About to list stuff got all these frames. Okay. So I would expect to have actually written these to tempter/there. So it means my ffmpeg might not actually be outputting these frames. I would expect to see that there. Let's make it a second temporary directory. Okay, so let's rename this to all occurrences. We want this to be tempter temp. What did I call it? I called it video. Temp video dir, and we're going to ask for a second temporary directory for the frames. Because why not? Temporary directories are cheap. Okay, so we're going to find the video in the temp video directory, which is also, so we're downloading the clip to the temp video directory. And now I have two different names, a clip and a video, whatever. Then we're going to take the temp video directory, and we're going to put the clip in there. We're going to do the extraction of it. Then we have a temp frame directory, which we created up here, but should still be empty, and we're writing our frames to there. Then this should, in synchronous, list all of those frames. And so frames should contain a list of frames. All right, well, we can't do this on a local REPL because we're basically what I'm doing is I'm inspecting the state of the remote system. So we're going to have to deploy that and give it a kick. And we're going to have to wait through the longer dev cycle. Yeah, this is a sad situation for me because one of the things that I've generally noticed about software development as a whole is I will have much greater success the faster I can make my kind of like dev eval loop. So like having multi-stage deployments and all that stuff can really slow it down. And it slows it down in a way that your brain doesn't really seem to recognize as much because you feel busy and you feel accomplishment every time the deployment happens. But it is totally a huge drain on your productivity. But I don't know if I want to stream right now a bunch of me tinkering around with my dev environment right now, because that's just not something I want to stream right now. Maybe next week. I'll focus on actually tightening up this dev cycle so we don't have to wait for this stuff to deploy so much. Okay, so let's deploy it again. And hopefully, I'm not actually sure this is going to fix the problem, but it will certainly, if the directory is empty, we know it's probably not extracting any frames at all remotely. It just said it was. And if there are files there, then I don't know what caused the weird logging message before, but it will be gone. So I expect to either see all of the frames listed there, Or, oh, it still ran the previous function implementation. I went too fast. Let's try that again. Ah, there we go. Coffeetime.mov. Unhandled rejection. Okay. It's because of the way I did my promises stuff. I had a rejection somewhere in there, and of course it doesn't tell me exactly where. Oh, it's still uploading. So that's it, still freaking out from that kind of overlap period. So now we should see it actually trigger. Function crashed out of the request scope. Function killed. That's interesting. I'm going to give it another kick again. So why that's freaking out like that, I don't really know. But I just, gave it the same input a couple times. I got a couple different error messages out, which is usually a sign there's something weird happening on the back end. So if I get function crash out of request scope, function killed again, then we'll know I've done something terribly wrong. Interesting. Got all these frames and then it listed that same directory. Am I listing the right directory? No, I am. No, I am. I am. Frame should be there. That's weird. That I don't really understand. Why is the video in my temp frames directory? Is this the same directory? That's interesting. Let's log these both out and see if I asked for the temp directory. I'm assuming it was giving me a new directory every time I called this function, but that is an assumption I made. Oops. So this is a OS method. So const equals require OS dot. Is this just giving me like? Let's just run this a couple times and see what it gives me. So my assumption was that every time I call it, it gives me a unique one. No, it's actually a single unique one for the entire process. Okay, so that didn't get us any closer to the solution. That assumption I made was a silly assumption. So let's undo all that stuff. I should have tested it locally on the REPL before I proceeded. So what is going on with this thing anyway? Is it not actually extracting any frames? Because that would be sad. Like it's running and it says it's running, but spawn. Okay. So my assumption now is that I have, because I don't really understand promises that much, I have it wired up all stupid and I'm doing something dumb in terms of how I'm spawning that child process is like monkeying up the chain of promises. And is this actually how I'm doing my... Okay, so I already have this implementation. So then when I spawn, so where is it actually spawning here? Okay, so promise dot child process. That returns a promise. So spawn command creates a promise which has the child process in it, and this is it inspecting that child process. So I guess that means I should be returning that. Oh, here, this one I do return it. If I go further up, I'm actually returning it, and this is the previous function we wrote, the GIF creation from the frames, and I actually return the promise from spawn in these, which means I should probably be doing it down here. And I'd be lying if I grokked why that's the case, but this at least might give us more clear insight into what's causing this to. And I guess it might have been kind of working before because it was the last one, maybe. Oh, there's no semicolon. Okay, let's do this big old long thing again. Let's deploy it. So we've successfully learned a little bit about the temperature function. So there's a temperature directory, and I assume because there was this big old string of gibberish-looking stuff, the temperature directory was unique per call of this method. But no, it's actually probably unique per process. So if I spun up 2 node instances, I'd probably get 2 different paths here. So we're deploying frame extract again. And while that is deploying, which I will move down to here, you can watch it finish deploying, I'm going to do a little research in parallel to see if I can clean up some of this stuff. So node file system, or we'll just call fs promises. Oh, fs promise, or fs promised is now deprecated. Use fs extra. Adds file system methods that aren't included in the native fs module and adds promise support to the fs methods. Hey, that might be what we want. This is no longer necessary. Instead, you can do this. Okay. So once that's done, okay, then how are we going to change our code to do stuff? So this is just about synchronous versus asynchronous. But I don't see I don't understand in terms of promisifying it. Async with promises. So fast that copy. Oh, and then. Cool. Okay, so it's deployed now. And while I try and grok that, let's give this a kick. Let's upload that same file again. And it could be that the act of uploading this file is actually just giving it enough time to do whatever weird settling it needs to do, and the chirping from the deployment might chill out. But let's find out. And hey, what time is it? It is 3:23 now. So this is from the previous execution. Oh, this is actually, okay, so a bunch of weird stuff's happening after it thinks it's done. So it's extracting frames again. And hey, it actually waited and listed all the frames. Oh, that's so exciting. Okay, so now I need to make a decision. Do I want to create some subdirectories? 38 more. So there's about 130 of them. And okay, so function execution took about 15 seconds. Hey, that was like twice as fast. I might actually just work with these bitmaps because I have a lot of network bandwidth to work with. And if I care about absolute time of this execution, which I do, I might just work with these bitmaps, which seems silly. Okay. So we have our list. And it being synchronous isn't that big a deal. So did I actually upload them? They told it to try and do an upload. Let's see if it was able to actually upload any of those. So those would be in storage. And there is a frames bucket, which has nothing in it. So it was able to create them and it was able to list them. So what I have here is I'm doing this. This is actually, I think, returning. This is promisified, I believe. So actually, I can test. I can see if it is because I did an upload here. So what I want to do is I want to queue up all these promises and add them to a list of promises. So let upload promises is a new list. So we're going to push them all onto this incredibly long command. It's so long, it is now wrapping. And I think this will do what I wanted to do. I think this will make it I think this will make it like, let it take the time to upload everything. But again, I'm still kind of fumbling around in Promised Land. I only understand it at the most vague level. I don't know why it's hard for me to wrap my head around this change in designs. But sometimes that happens. Like, it took me a long time to really understand. Like, if anyone's any like RX Java work with Android, it took me a little while to wrap my head around that development style also. Or it could be that my only real experience working with promises is in the 90 minutes when I'm nervously live coding on a stream. That might be part of it also. Because like, I have to admit, coding while live streaming is, there's a section of your mind that you spend dedicated to not leaking out any like secrets and just making sure that you're keeping whatever code you're working on interesting to the people watching. Because there's a lot of time when when I'm coding, when I just sit there and read reference documentation for an hour, which I'm pretty sure you don't want to watch me do. Even if I read, and if I read it out loud, I'm actually retaining less than if I read it silently. Okay, so we want to upload our coffee time movie again, which the storage bucket probably thinks is the most exciting video ever. While it's uploading, we'll go look at our function logs. We care about one specific function, our frame extractor. And this is from last time, this unhandled rejection. And I think this is because like the function is returning before. Oh, it was going to happen right now. So okay, so it got all these frames out. It's actually going to upload everything, including the original movie, to the destination bucket. So we need a way to filter that out, or we need to use a different directory, which means we'll have to create a directory, which means I need to learn a little more about file systems, which is probably the best solution. I think that's probably the cleanest way, the least brittle, less brittle than trying to like just subtract specific files or run a regular expression on these. I think those ways of filtering out and getting only frames up are a little more brittle than just creating another directory, trusting that when it's created it will be empty, and so on. So, still cranking away. And hey, it ran for a minute and it eventually timed out. So, how do we solve that problem? Well, first of all, let's go take a look at storage and let's see if it uploaded any frames. There are no frames there. No frames at all. Well, let's just make it have a longer timeout. So we're going back to the Cloud Console, and we're going to make the timeout longer. Why not 500 seconds? That seems good, right? Let's let it run longer. And 5 minutes, that's a long time for that one function to run. But I think that's okay, at least for the development cycle. Because the other thing I could do to tighten up development is just upload a shorter video. In fact, I might do that right now, because we have to wait for that little spinner to finish spinning. So we're going to go into give function. We're just going to make coffee time. Coffee time 5 second move movie, and we are going to we're just going to trim it down. So if I want to trim it down, it's dash. I had a command for this somewhere. Let me take a look at my command history. Slightly off screen, because I've done video chopping before. So what we want to do is we have our input file, and we're going to chop off the first 3 seconds. Why not? And we're going to copy it. So what this is doing is just chopping off the first 3 seconds of that video. And now we have a new coffee time, which is a little smaller. It is only 3 megabytes, and more importantly, it is like shorter. It's like half the duration. Actually, I can take that to the next level. Let's chop off the first 4 seconds. We'll overwrite it. And hey, it's down to about a megabyte. So we're going to go back over into storage. We're going to upload a file. We're going to upload our new, tinier, faster, easier to deal with, which will be less likely to make our function timeout in its currently less than awesome implementation. And this shows it there twice, which is a little weird. All right, there it is. So let's go back to our log, and it's already running. And it didn't do all the logging I would have expected it to maybe log. Let's try uploading it again. Maybe it extracted 0 frames, which would be interesting. Maybe there's something I did with that thing broke it. Let's find out. I don't think it extracted any frames at all. Okay. Coffee time to coffee time tiny. And we'll take the 5-second one and call it back to coffee time.mov. So we can trigger this again. So upload the big giant one again, overriding it with the like 8 megabyte version, which has tons of frames and caused our thing to time out last time and made me make all of you sit there for like a whole minute while it was processing. So it looks like the UI just displays 2 frames sometimes, or two listings sometimes for a thing. And hey, it's running, it's downloading, it is extracting frames again. This is where it took about 20, or was like 10 seconds last time to extract the frames, I think. Oh, I don't have to guess, I can go look. Took, well, when it did this 60-second execution, when it timed out, it was doing frame extraction for some number of seconds. Let's give it the time to do its thing. This is where it's, oh, there goes one new log entry. It took long enough that that started to go. And it says no frames were extracted. Why did this stop working? Did it upload any frames to our frame thingamabob? No. This is disappointing. Seems I've broken it. Which is a little bit annoying. Okay, so why is it broken? Let's try uploading it again. Because I don't know if I believe that it's this broken. See if I've done anything while that is doing uploading and it's running. Let's see if I've done anything obviously silly in here that would cause it to break. Well, other than the obviously silly things all over the place here. So we're still reading from the temp video directory. Let's rename that back to tempdir. Tempdir. Do some refactoring while it deploys. So we're writing those back to that directory. Then I'm listing all of them. Did it say about to list stuff? Extracting frames, and then it just stops. Maybe it's taking so long to extract frames. Or during the frame extraction, something else is breaking, and I'm not handling the error case, so it's just following through. Because I know right now I'm assuming happy path. I'm assuming everything is working great. Well, that's not what I want. Okay. So why are you broken, thingamajig? Why did that stop working? This is a frustrating time in these things sometimes. Well, it was running when it was shorter. I wonder if going back over to, did anything get changed here that might be doing it? Let's try doing the equivalent of a, okay, so frame extract.
I may have a much longer timeout. Let's change that back to 60, since that seems to be the only thing I changed. Let's see if that somehow automatically fixes it. So it's gonna do the configuration change, which involves more dancing around. And it is warm in here today. Yeah, actually, because I live in San Francisco, I have no air conditioning. I do my streaming from home. And it must be like 90 degrees in here right now. So I might actually call it a day a little earlier just because it's hot. I don't want to get cranky while streaming. Okay, so we have this again. We're going to try uploading again, replacing that file with the same 8 megabyte version. And there it goes on up into Cloudland. This will, in a few seconds, trigger the log entry to appear, and we will see if for some reason changing the timeout of that cloud function from 1 minute to 500 seconds all of a sudden made this explode in a fireball. What's weird is like the frame extraction step is actually taking some good chunk of time to run, which is why I'm surprised that it like doesn't have any side effects. Like then the following log entries aren't called. I'm not seeing anything in the destination bucket, and so on. And this is one of the downs, like one of the tricky parts of like serverless development in general. When you've abstracted away a lot of your server resources, it's harder to do a lot of the same sanity checking that I'm used to doing when I have like a compute node. Like when I have a compute node, even though like it's a bad practice, I can log into that compute node, poke around, and like, you know, detrace processes and stuff like that, which is something I just can't do from here. I can't see the system calls. I can't see the local file system manipulations. I have to do everything indirectly through code. Okay. Well, it is still broken. I'm not sure why, but I think I'm actually going to be wrapping it up for today, mostly because it's just gotten really hot here. It might have something to do with my streaming computer next to me running at like 100% CPU for pretty much the whole time. This made my little corner here a little bit warm. Okay, so I'm going to wrap up for today. I'm going to poke around and try and come up with a solution so we can move through this chunk of it a little bit faster. I'm going to get back to the stream next week. So let's wrap up. That means bringing up this spreadsheet thing again. So where did we go? So we spent almost the entire session on just trying to get that thing deployed to Cloud Function and reading the source video from the bucket. We didn't spend much time tinkering around with the local dev environment. So we spent all our time here, and we made some progress on it. So incomplete. Is there anything I can do to like signify that? I will italicize it to indicate that we're kind of actively working on steps 3 and steps 4. So doing that same thing from a deployed Cloud Function and getting the video from the storage bucket working. I think what I'm going to do in the meantime before the next stream is I'm going to work on this step here. Get everything running, like basically get a local dev environment working. I'm going to get that working offline, and then what it'll do is it'll really tighten up the execution time so I can do those kinds of like detraces and other digging around at a lower level. Yeah, and that'll make the stream have a little bit higher pace next time. So this is what we worked on. We've got it deployed. We got ffmpeg binaries working from the cloud, and that is definitely a success. But it's kind of flaky. So I need to figure out why it's flaky, which is probably something to do with the fact that I don't really understand promises. So I might actually go back and just do that with callback hell instead. Make sure everything's working, and then refactor it into a promisey implementation. So I'll tinker around with that and come back next week with more awesomeness from Poland, bandwidth allowing. So if you're still watching, thanks a lot for tuning in. Have a wonderful week, and calling it off for today. Thanks, everyone. Bye.